that if you keep object closer, that will subtend more angle. Okay, suppose here this is the eye and this is the least distance for clear vision, and let's say this is about 20 or 25 centimeter. If you keep the object here somewhere at a distance further than d, the object will subtend less angle. If you keep the same sized object here, this object is going to make more angle. This object is going to subtend more angle. So I am just taking that smallest distance. So when you keep the object at the smallest distance, which is least distance for clear vision, then that object is going to make more angle at the eye. Let's say this is the angle theta naught. This is the angle theta naught. So unaided magnification. So if object is here somewhere, it will subtend less angle. So we see the object size less. But when you keep the object at D without any help of a lens, this is the maximum angle it can produce. So the size as perceived by the eye, size is directly proportional to angle subtended, and theta being very small usually for objects at the eye, so tan theta equal to height of the object by the distance. So this theta naught is equal to h by d. Theta naught is equal to h by d. When this value is more, then we see the object bigger. So this is the closest distance we can keep. So without any help, this is the maximum possible magnification. We call this unaided magnification. Unaided means without any help. So unaided magnification of an object of height h is proportional to h by d. But we can also try to bring object even closer by this. So here is where you kept, but if you use a small lens or something, instead of keeping at a distance d, you can right now keep the object even closer to the eye, because what this lens will do, the lens closer to the eye, we call it eyepiece. What this lens does is that this lens will form the object's image somewhere here, so that the eye will only be able to see this image. Right now you see, when the object is here, it subtends greater angle than this theta naught. You see the object's image is formed here. So this angle theta is the size of the object as seen by the eye with the help of one lens, which we call eyepiece. So right now from the lens, the object is at a distance u. Let's say eyepiece means it is ue. So the image is formed here at a distance v. So we call it ve. Okay. So right now the size as perceived by the eye is proportional to theta, which is nothing but the same height object. It is now at a distance u. So h by ue. So compared to unaided, so what is this is with the help of one eyepiece. So with an eyepiece, what is the size of the image or magnification produced by the eyepiece with compared to this? So this by this. So size with eyepiece is theta, size without eyepiece is theta naught. So magnification produced is equal to theta by theta naught, which is h by d, h by ue divided by h by d. So h and h will be cancelled, d by ue. So the magnification with the help of an eyepiece is equal to d by ue. ue is the position of the object. ve is the image formed at a distance. So this ve is human eye can see from where to where we just discussed in the previous video, at a closer distance of d, which we call near point, and the furthest distance object can be seen by the eye equal to far point. The far point, we said it is literally infinity, and the near point is 20 to 25 centimeters, which is usually given, represented by the letter D. Sometimes for problems they will give 20 centimeters, sometimes for problems they will give 25 centimeters. Okay, so the magnification. Suppose if you want to cover these two distance, you can choose UE so that final image can be formed, at infinity, or you can choose UE such that final image is formed at near point. So because the final image is formed at distance, which we call least distance for clear vision, then this is called near point adjustment. This kind of, if we choose UE such that final image formed at infinity, means that is called normal adjustment. If you choose UE such that final image is formed at near point, then that is called near point adjustment. Suppose for final image is to be formed at infinity, let me take the case for a lens, because this is a lens, so 1 by V minus 1 by U equal to 1 by F. Okay, so V should be, U is the distance in front of the lens, so it is UE, final image is VE, and this is the eyepiece focal length FE. So the final image is to be formed at infinity, so UE must be, because all light is coming from object to eye in this direction, but you have to measure the distance from the lens to the object. UE is actually negative always, so V has to be infinity, so 1 by infinity minus of 1 by minus UE equal to 1 by FE. 1 by infinity becomes 0, so 1 by UE equal to 1 by FE, which means UE equal to FE. Suppose if your UE equal to FE, final image is formed at infinity, hence magnification produced in the normal adjustment equal to D by FE. Okay, now final image can be made to form at least distance for clear vision. That means like this. So here is the object, eye lens. You keep the lens over here, and we have kept UE in front of the eyepiece such that the final image is formed at here at D distance, least distance for clear vision, so that the both are like forming an angle here. So here what should be the distance UE? So 1 by VE minus 1 by UE equal to 1 by FE. For eye to see the object of height h must be formed an image here, only then I could see this. Okay, so UE is in front of the lens, image formed by the eyepiece is also in front of the lens, so UE and VE has to be equal to D, but since both are in front, this is also negative, this is also negative, so 1 by VE equal to minus D minus of 1 by UE equal to minus UE equal to 1 by FE. So minus 1 by D, so I'll take that there, so minus into minus plus 1 by UE 1 by FE plus 1 by D. This is FE into D, here FE plus D, so UE must be equal to FE into D by FE plus D. So we can choose to form, in order to form the object's image at near point, UE should be equal to FE into D divided by FE plus D. Hence magnification, as we discussed, magnification is D by UE. Magnification must be equal to D by, in place of UE we will be substituting FE into D by FE plus D. So that means that this D and this D will be cancelled, this goes up, Fe plus d by Fe. Fe by Fe is 1, d by Fe. So magnification is equal to 1 plus d by Fe. Hence, there are two magnifications possible. So the range of magnification from normal adjustment to near point adjustment. Normal adjustment means final image is formed at infinity. Near point adjustment means final image by the eyepiece is formed at D. So magnification in case of normal adjustment D by Fe. Magnification in case of near point adjustment 1 plus D by Fe. So the corresponding distances. So for final images to be formed at infinity, here we said UE equal to Fe. So I'll just summarize here. Magnification by the eyepiece is D by UE. So there are two possibilities. When UE equal to Fe, final image is formed at infinity, hence magnification is equal to D by, in place of UE we are supposed to substitute Fe. This is normal adjustment. When UE equal to Fe into D by Fe plus D, final image is formed at infinity. V equal to minus D. When UE equal to Fe, V equal to infinity. So this is called normal adjustment. Magnification is D by Fe. When UE equal to Fe into D divided by Fe plus D, final image is formed at near point. In this case, magnification as we worked out 1 plus D by Fe.